Radhe Radhe everyone. I think I'm live right now. I think it is, you guys can hear me and see the screen also, okay, right? Okay, so करते हैं शुरू. Yes, tell people. Okay, people will be joining. No problem. So let's start with today's first question. Okay, process string with special operations. One. You're given a string S consisting of lowercase English letters and the special character star, hash, and modulo. Build a new string result by processing S according to the following rules from left to right. If the letter is a lowercase English letter appended to the result, a star removes the last character from result if it exists. A hash duplicates the current result and appends it to itself. A modulo reverses the current result. Return the final string result after processing all the characters in S. So whatever is written in the question, we are going to do that only. Nothing else. This is a very simple question. And this took me 3 milliseconds, so I hope you can understand. Like, this is a very easy question. So you're given this string. Now what you can do is, since I was using Java, so I was using string builder, but I think C++ and Python has got its own different versions, but string builder is like, it is just there for mutability. Okay, Java's inbuilt string is not mutable, it is immutable. So if I want to modify it, it takes big O n every time. Okay? That's the reason. Even if I would have gone for this normal string, then also it would have worked. Okay, nothing wrong signs. So I'm going to like traverse throughout the length, and I'm taking the character at every position. And if the character is a alphabet, a lowercase alphabet, then I can directly append that to the string. Otherwise, if it is hash, then I can, what was it? It was like we have to duplicate it. So we are going to append the same thing to it. If it's a star, then we have to delete the last element. But what if like the length of it is zero only, right? So it may happen that the length of it is zero, so we won't be deleting anything. So we are also doing one more check that if it is not equal to zero, then only we are going to delete the character at sb.length minus one. That is the last character. Okay. Otherwise, if it's a modulo, you're going to go for reversing the string, and then you can return the sb.string. This is an accepted solution. I don't think this needs much attention. So I'll move on to the next question. Actually, this is a very interesting question, a good question to be honest. It is minimize maximum component cost. You're given an undirected connected graph with n nodes, which are labeled from 0 to n minus 1. Normally, it is done like that only. You're given a 2D integer array edges, where edges y is equal to ui, vi, wi. That is starting point, ending point, and the weight of it. But now, since it's an undirected graph, so ui and vi is not going to matter for us much. Okay. So it denotes an undirected graph edge between node ui and node vi with a weight wi and an integer k. So what is k? We are going to understand it now. You are allowed to remove any number of edges from the graph such that the resulting graph has at most k components connected. Okay. The cost of component is defined as the maximum edge weight in that component. If a component has no edges, its cost is zero. Okay. Return the minimum possible value of maximum cost among all the components after such removals. Let's understand what it means. What it means and how we are going to approach it. Both are important. Let's say uh, you have got a graph. Was it a graph or a tree? I don't remember. I think it was a graph. Yeah, it's a connected graph. So you have got a graph and you have got some edges. Okay. Now you have to make key components. You have to make like you can make one component also. Okay. You can make 1 to k any number of components. Okay. Now see, initially how many components are there? 1, 2, 3, 4, 5, 6, 7. Right? 1, 2, 3, 4, 5, 6, 7. So initially there are 7 components. Now let's say the value of A is 3, which means that I have to make at least, I have to make it at least 3. This 7 I have to make at least 3. So what I can do is I can go on connecting it with edges. Now the moment I connect this with this, now this becomes 6. Right? Then I connect this with this. This becomes 5. I connect this with this. This becomes 4. Right? Now if I connect this with this, it becomes 3 and I get the answer. Okay. Now, um, one thing is very much clear. So I mean, yeah, you can connect it like this also. You can connect it and you get the answer. Okay. Not an issue. Now, one thing that you can see over here, that is on connecting, the more you connect the edges, the lesser the components become. And your target is to make it k, or even less than that also works, but you won't make it less than that, because your another target is to keep the maximum edge minimum. Okay, so this is a very greedy algorithm, more similar like I think it's Prim's or Kruskal algorithm, I don't remember, where it is the MST, minimum spanning tree type of thing. Okay, it is very similar to the minimum spanning tree, but a little bit of modified version of that. Okay, in minimum spanning tree, what you do is you just go on doing it until and unless you find that there is only one. This k becomes one, but instead of getting it as one, we are going to go for whatever the value of k is. Okay, so this one is not valid, so it is similar to MST, but you don't have to do the complete traversal. Now, what you can do is you can sort the edges. Okay, you can sort the edges on the basis of weight. Okay, W. Now, once you're sorting it now you know that you got the minimum edges, right? So you go on adding the minimum edges over here. Okay, you go on adding the minimum edges. Let's say, oh sorry, I can't do that. Let me erase this. Let's say for this example only. Okay, now I go on adding edges using minimum width. Okay, so let's say this is an edge. This is the first edge that occurs. This is the second edge that occurs. Now, how many components are there? 1, 2, 3, 4, 5, right? But I have to make it 3. Now, the next edge, sorted according to weight, occurs over here. So, the number of component is not decreasing, right? The number of components is not decreasing. But we have to go like that. Okay, we have to include that. Or you may also ignore that. That is not a major issue. You may also ignore that. But it's like we are just going on the, let's say this is having a weight of 1, this is having a weight of 2, this has a weight of 3, now this has a weight of 4, this has a weight of 5. So how many components are there? 1, 2, 3. We got 3 components, right? We got 3 components. But let's say if this 5 was not over here. Okay, this 5 was not over here, rather it was over here. Okay, it was over here. So then it will be still 1, 2, 3, 4, 4 components, right? So we have to again go for it. Now let's say if it is like this, 6. Now it is okay. Good. Okay, so we have to do it on the basis of minimum. Okay, you're getting it? Minimum first, then go on doing it. Now what is the minimum of this maximum? So the maximum is 6, right? And this is the minimum maximum that I can have. Okay, get it? This is the minimum maximum that I can have. So it is minimize the maximum. Now let's look into the code. It is a very DSU basic question. So I have used DSU over here. So you know like what DSU is, like it is destroying set union thing. So I have made a class for it. I have made a find a union for it. The union will be down. And I also make another component which is not usually much visible on a DSU. That is I am having a getter function for the number of components. Okay, because I will be needing it. Now see, if k is equal to n, this is the main function. Okay, If k is equal to n, it means that the number of components that I need and the number of vertices that are there is equal. So we don't need any edges only. So we can return 0 directly. Otherwise, what we are going to do is we are going to go with the traditional method. That is, we are going to sort the array of edges on the basis of weight. Then I am going to make a DAC out of it. Then answer is equal to 0. And for all the edges, okay, I'm going to perform a union of u comma v. Okay, and then I'm going to check the DAC of component, the number of components in it. Is it lesser than equal to k? If it is lesser than equal to k, answer is equal to w and break. Done. I'm done with it. Otherwise, you again go on making the union. See, one thing you must know that whenever there is an and, it means that this part will be there. This part will be happening. Okay. So for every part, for every edge that you get, we are going to make a union, and then you go on making it. Okay. Until unless you find that okay, now the number of components is less than equal to k, so I am done with it. And what is the last weight that I have indulged in it? That is w, and this is the maximum this is the minimum of the maximum that I can have, and you can make the answer, return answer. Okay. Or one more thing, much easier thing, over here you can directly return w. Okay. What do I mean by that? I'll just show you. This is my code, right? Instead of having an answer over here, you can return 0, and over here you can return w. So if it's like you are really thinking of reducing the LOC, so you can do this. In that case, you will be not needing this also, and this will pass. Okay, this will pass. I can guarantee you that. It will pass, man. It will pass. Still giving it a try. I'm sure that this will pass. Okay, it passed. And it is also 60 milliseconds. So this is not a much enough an issue. Okay, so we are done with it, right? Let's go to this question, the last question. The second question, the third question I'll tell you. It is basically nothing but a modification of the first question, where instead of getting the what do you say? Now instead of getting the mm, whole string, they want to get the character at k. Okay. A completed second year, what type of projects must I add in my resume, and what recruiters ask you from a project? Should I learn all technologies from scratch? See, if you're making some projects, na, so you should have a basic idea on that. But remember one thing, like if you're having multiple technologies in your project, like let's say if you're making a project, obviously you're making a backend project, let's say. So you won't be keeping it just backend, right? You have to make it full stack. Now you let's say if you're making a Java project or a Python project, okay. Now it is not like कि completely वो पूरा Java का है, ठीक है? There will be some UI, there will be some UX part of it. That is React. Now the moment you going to the interviewer, like from my point of view, it is different, okay? Because I'm a completely Java centric guy. So for all the interviews that I go for, I'm completely working on Java, okay? But like if you're thinking कि you have to choose something among them, you can choose it, okay? Uh, or like you can do one thing, whatever you're doing, the main part of the project. Okay, so if you're making a full stack project, remember one thing, for full stack, you have to get the knowledge of the backend most importantly. Front end is okay, but the backend is most importantly you have to get. If you're going for front end project, then you have to go for front end knowledge. Okay. For front end, it's front end. For backend, it's backend, and for full stack, it's also backend. Okay. Because backend is a good thing to understand. Okay, to understand the logic behind it. Nobody is going to tell you that how much of HTML CSS you know. Okay, they are going to check how much of React, Angular, components, state management. Even I am getting TLE on this. Even I got a TLE. Are you getting TLE for 531 cases? Because like I couldn't think of any other better option from here. Yeah, 5:32, right? So I think did you check like yeah 5:31? Did you check like what it was like? क्या बोलता उसको? The solution. Okay, तो हाँ वही बोल रहा था मैं कि just go for like projects वगैरह, and if you're going to focus on something, go for the back end part of it. Like let's say if you're developing something in Merge stack, okay, something that is quite in craze in the market, or basically for freshers, Merge stack is quite much fresh, right? Now, what if someone asks you like, what is a node? What is node in this Node.js? Okay. So it shouldn't be like you have got no idea about it, or maybe someone may ask you. So I'll just tell you, if you're having a Merge stack question, and if I'm an interviewer, it is not going to happen. Okay, like I'm not that much experienced on this shit, but if I'm your interviewer, so the first thing that I will be going through is your backend stuff. Okay, backend reliability I will go through, but after that I will go through like I'll just ask you, because I am not sure like what the heck is Merge stack, and I'm not interested in that also. Okay, I'm interested in taking a candidate. It is proposing a TLE for 14 only, no, where every edge is connected. So this makes it 12:30. I get it. इसमें TLE I was expecting a TLE on this, but I was not expecting this condition in it. Okay. तो क्या बोला था मैं कि हाँ तो like that is only the yeah, first question that I will be coming up with, which it is actually difficult for freshers to answer, is why are you using MongoDB in this and not SQL or not any other database? ठीक है. So if you're making a merge stack project, you have to be quite like what to say, like you have to be quite understandable like why you are using that tech stack. I think my laptop is going to discuss in just a minute. My logic is question to run DFS for all the nodes is complicated. It would be 14 into 4. No, 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 no. Uh, your it should be how many edges are there? There was no this thing on edges, na? You are actually right, but were you using recursion for this or memorization or DP or anything like? I think you were. I think we should have used tag for this. Then it would have worked, I guess. I'll ask Gemini. But what I felt is like this is going to be nothing but 12 factorial. Okay, 12 factorial. Like for 14, it has to be 12 factorial in the worst case scenario. But you're also right that DFS is going to go for B into B plus 1. This is also right. Let's see. So yeah, minimize maximum is done now. Let's go for longest palindrome only. Okay. So I'll just go for this question. Shouldn't work that way, though. But I'll just give it a try now. Runtime error. I'm not even checking like what the code that Gemini is giving me. I think I should give it a check. If it is like you're using stack for this, will BFS be a specific thing? It is going to give it to you. I need to come up with a good approach. I need to come up with a good approach. Let this get compiled till then. So till then, I'll just go through what the code is. Okay. Longest palindromic path in graph. You're given an integer. Wrong answer. Oh, okay, okay, okay. Not this one, not this one. This one. You're given an integer. अबे यार, n and an undirected graph with n nodes labeled from 0 to n minus 1, where edges are given. You're like it is basically I'll just tell you what it is. Okay. It's like you're given some, you're given a graph and you have to find the longest. Like okay, you're given a graph and the edges and all the nodes are labeled something from A to Z. Okay, A to Z. Now you have to find the longest palindrome that can be formed from a path. Okay. So for let's say this example, this ABA is a path, right? So ABA is a palindrome also. This AA is a path, so AA is also a palindrome. ACA is a path, ACA is also a palindrome. The longest palindrome is 3. Okay, so we get the answer 3. What I have done is, I'll just tell you what I have done. See, since I know that I can start from any node, okay, so I'm starting from any node and then I'm going to traverse throughout it, okay, using a DFS. That is a kind of, let's say, it's a two directional DFS, okay. There are a lot of directions, okay, over here. There are a lot of directions over here. But let's say I get two nodes from here, from this whole thing. I get two nodes which is same. Let's say this and this are same. Let's say this is A and now this is a B and this is also a B. Okay. So I will go for A, B and A, B. So I will just go for the same things. Okay. Let's say this is a C. And over here there are three nodes among which this is a C. And this is also a C. Okay. So I will go for A, B, A, B, A, B, C, A, B, C, A, B, C. And I go on doing it. because this C and C, so whatever is same in this, okay, so that is I am having a 2D DFS. Now see, for A, for DFS, when I am going for A's DFS, I'll go to B and B, right? I go to B and B. Now the next time when I am going for the next DFS, now I am going to check for B and B. So for B and C I can go, and for this B and C and B and C I can go. Okay. So one pair will be this BC and this BC. The other pair will be this BC and this BC. Okay, you getting it? So you can go on doing it. Okay, from further branches you can go on doing it till you find that it is going to be the same. And the moment you get it, so it is like from A, whatever is over here is the same thing as it is over here. Now if you traverse it like this, it will be a palindrome. It will be a palindromic path. So that is what I have done. Okay. If you want the code, I can show you, but it's a TLE. First of all, let me clarify. This is a TLE, but for you, I can show you the code. It is like I'm getting the adjacency array. I'm getting it out of it. I'm making a visited boolean. Then I'm going for all the visited things. I'm making it true, and then I'm just continuing the traversal from I comma I. Okay. But remember one thing. Let's say for this scenario, this is a good scenario. But what if like this? This is A, and there are two nodes that are coming out from A. This is A, and this is B. Now since A and B are not same, so we are not going to take any pair, right? But that is a wrong concept. Because it may happen that over here there is a B. Okay, and this BAAB is a palindrome also. This A may not be the middle element because the length of the palindrome is even. So for that case, we are also going to check for all the neighbors which are equal to this A. And then we can continue the traversal from this part and this DFS. Now DFS, this is B and B, matching. Then go on from the branches, okay? Now let's see what the code I am doing. So first of all, I am making a DFS from I and I itself. That is from the same point, same source I am making it. And the length of it is 1, okay? Because that is only considering one node. Then I am going to check for all the neighbors. And I am going to check if that character, that is the label at that position and the label of that neighbor is same, then I can make that, okay, I have also visited the neighbor. And now I can have one source from I and another source from me. That is a neighbor. Okay. And what is the length? Length is 2. Because if I am considering this, I have already considered a length of 2, right? That is the length is 2. And then I am going to revert it back to false. Remember to revert everything back to false, whichever you are making it true, okay? Then I am going to go for the DFS. What I am doing for the DFS, answer is equal to current. This is basically nothing but I have just initialized it. It is not needed. You can directly make it answer is equal to current. Not an issue. Then for every neighbor of U and for every neighbor of B, I am going to first of all check that if U not equal to V, which means that if I am both the sources are not pointing to one specific element, that is I am not at this position. I am not at such a position from where I am going to traverse from the same part. Okay. So this is the condition. Why we are taking it, I'll just tell you why. Or neighbor of U is not equal to neighbor of V, which means that it may happen that this is a graph, okay, and I am going to go for multi-dimensional. Let's say this is A, and this is B, right? Now let's say this A and A. So according to this is satisfying, right? Now if you look at it carefully, A is also connected to B and A is also connected to B. Over here also it's the same thing. So the length will be coming as 4, right? But it shouldn't be 4, it should be 2 only. Because this B is common in both of them. So we can't take that. Okay, so that is the condition that we are going to check for. That if both the neighbors are not same. Okay. If the neighbors are not same and the label at neighbor U and label at neighbor B, both of them are same. This is the main condition that we were already checking. Okay. In that case, we have to go for this traversal. Okay. This traversal. But also before that, you have to check that whether if both of the neighbors has not been visited earlier. If any of the neighbor has been visited earlier, we can't go for it. Okay. If both of them hasn't been visited earlier, make them visited, then go for the DFS. When now the new U is the neighbor of U, and the new V is neighbor of V, and the length of it increases by 2 because we are going to take the neighbor of U and neighbor of V. So there are two nodes that are going to be added extra. Okay, clear? Visitor neighbor U. Now again revert back. Remember, you have to always revert back in DFS, right? So you revert it back, and then you can finally return the answer. Okay. So I hope this question is clear. The answer solution is also clear, but I'm not sure about this. I think the editorial is out, right? Is the editorial out though? It should be out by now. एडिटोरियल कहाँ दिखता है भाई इसमें? पेज नॉट फाउंड है भाई. How come the page not found is happening for this? ठीक है, कोई ना. I don't remember. Can you guys tell me like how to revert back to the original version? This is the new version of Leetcode ना. Original version में वो दिखाता था discuss ऐसे side में. अच्छा हटाओ भाई, तो बहुत ज़्यादा लगा रहा है. इसी को हटा देते हैं. ठीक है, let's rate down the problems first. Okay. Okay, चलो फर्स्ट वाला तो भाई इजी था. सेकंड वाला मीडियम का ऊपर रखूंगा मैं. नहीं नहीं यार, सेकंड वाला हाँ मीडियम के ऊपर ही रखते हैं. थर्ड वाला हार्ड था. फोर्थ वाला ना थोड़ा नीचे था. एक काम करते हैं, डी को इधर रखते हैं. बी को इधर रखते हैं. ठीक है. सी डिफिकल्ट था भाई. सी ना इट वाज लाइक फर्स्ट ऑफ ऑल आई केम अप विद अ लॉट ऑफ अप्रोचेस फॉर सी. ठीक है, मेरे दिमाग में ऐसा चल रहा था कि सी को ना वैसे बना दूं, क्या बोलते हैं उसको, लिंक लिस्ट से बना, या फिर डबली लिंक लिस्ट से बना दूं. ठीक है. सो इट्स लाइक कि भाई ऐसा 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 आएगा, लाइक दिस इट विल हैपन, एंड उसके बाद मैं उसको रिवर्स कर दूंगा. ठीक मैं ये सब सोच रहा था उस टाइम। बट इट्स नॉट गोना वर्क लाइक दैट। प्रॉब्लम वही है, इट्स नॉट गोना वर्क लाइक दैट। ओके चलो यार, गुड नाइट यार, हो गया आज के लिए बहुत। आज मैंने सुना वो कोर्शे वाला भी है इसका, कोर्शे वाला आ जाएगा। पता नहीं यार, आज तो मतलब आज थोड़ा ये है भाई, कम लोग हैं शायद। चलो यार कोई बात नहीं, चलो ओके, बाय गाइस, बाय गाइस।